Cargo de Jessica Ingrassellino y ella va a dar un taller acerca de Automated Acceptance Testing. Espero que les guste. And we welcome Jessica with an applause, please. Thank you. You can start.
So, hola, me llamo Jessica Ingrassellino. Me siento muy honrado de hablar hoy. Me disculpo que mi español es pobre, que debo hablar con usted en inglés hoy. As you can see, my Spanish is not so good, so I will be speaking in English today. I'm honored to be here with you, and I'm sorry I cannot be live with you in Mexico City. I hope that you're having an amazing conference. So I am a very active software tester, and I have done software testing and written test automation frameworks in Python and Ruby for Nomi, Bitly, Rent the Runway, and now at Salesforce.org, where I work as a lead software tester. I'm very active in the Python community as an author and teacher of Python, and the chair of the Python Education Summit in PyCon, USA. Today, I'll be talking to you about a acceptance test development tool called Behave. Now, many Python developers think that they need to use another language like Ruby or Java in order to use the popular Gherkin syntax. But this is not the case. Behave is a tool that has been developed with a technique to encourage collaboration between developers, QA, and non-technical participants in a software project. Behave uses tests written in a natural language style and backed up by Python code. So what this means is that developers that are working in Python can also work in Python to write all of their testing, even their automated acceptance tests. So what Behave offers is an active development by the creator and a wonderful community who answer questions and take contributions on GitHub. This project is open source, so anybody can use it and anybody can contribute. It offers command line specifications to make it easy to integrate your automated acceptance tests with your CI system. So you can use an open source like Jenkins or a third-party solution like Travis or Circle CI. Behave also allows for integration with a local Selenium server or integration with third-party applications like Sauce or BrowserStack. Behave offers custom environment settings, which means that you can set steps that run to give data or remove data from the entire test for a certain feature, or even to pinpoint a certain scenario. The API allows for optimization of logging, as well as test design, so that way that you can get all the information that you need through the command line interface or through writing JSON output to a tool like Jenkins. Finally, Behave is supported in the PyCharm IDE, which makes development of Behave syntax easier, especially in the feature and the step files, which are specific to the style of test development. So behave has 3 pieces, and each piece plays a part. All of you are familiar with the Python language. Some of you may also be familiar with the Selenium WebDriver API, which allows interaction with elements on a web page. The Behave tool, written in Python, allows for the use of Gherkin syntax, given, when, then, which are used to express the test scenarios and interact with the Selenium API. So Behave is really better than manual regression. Many developers know about automated acceptance tests, but may not have written them, leaving this job to the testers. Yet it's important to know why this kind of testing can help you and your entire organization. First of all, using Behave, anybody can write test cases as feature files, even non-coders. So this means the requirements are clear for all the stakeholders. That also means that your test cycles can be spent testing complex areas of your product. Also, as with any other unit tests or integration tests, automated tests written in Behave can be run frequently and catch issues before release. So today, I'm going to describe to you the code base structure and elements that you would need to build a basic acceptance test setup using Behave. So the file structure needs to be very specific because Behave is looking for certain files to live in certain places. The Behave layer describes the tests. The step definitions are written in Python, and the page objects are written using the Python Selenium API. So we will go ahead and get started taking a look at the file structure. So on this file structure, you can see that there is a main folder called features. Everything for Behave lives in the features. The pages, the steps, and then the environment.py file and the login feature are all necessary components. Behave will not run without an environment.py file. So it needs that config file to run. Now, this is organized so that way that once you set it up, it is very scalable and many people can contribute to it. Now, the next important thing is this environment setup file. So the environment setup file helps you to determine what WebDriver you're going to use. So you can test in Firefox, Chrome, Internet Explorer, or you can do headless testing through Phantom.js. You can set environment choices. So you can test in your production organization or your development organization. You'll notice that there's before all, and I have a step called context.driver. From that step, I choose from the driver dictionary, and I can have my driver configured. And after all, I quit. Now, I can choose to only run a feature, and I can choose to set a browser only for that feature. So there's a lot of flexibility that you don't see in this particular example, but you can set your file to as many environment organizations as you'd like. You can set it to do data setup and data teardown. And you can set it to do all of this from the command line or through a YAML file into Travis or other CI programs. The feature file is one of the main communication points of using Behave. At the top, in line 1, you'll notice the login tag. So that tag allows us to specify the test from the command line, which is a very useful feature. Now, I've had to white out some of the code because I don't want to share proprietary tests. So in this feature, you see the scenario. Any business user, any salesperson, any customer service person can look at this and understand what the requirement is. So your scenario outline, given the user is on the home page, when I log in with a username and a password, then I am on the home page. Now, a neat feature of Behave is these examples tables. So I can test a positive test with a username and a password. I can also test a bad username and password and expect a failing test. In that example table, I can place as many username and password combinations as I want to test, and I do not have to rewrite the code. So this makes test writing and communication really, really clean and very dry. So the next step is to write out the actual components or steps that will take the actions in order to direct the WebDriver. So you'll notice in the top, I import from Behave, which gives me the @when decorator and the @then decorator. From the pages, I'm importing the login page. The login page contains my methods for logging in and allows me to pass in the arguments for username and password. The steps in a step file can be as numerous as you need. Step files can be organized by feature or by page, depending on the project that you are building. The page object file can be an entirely separate file that contains only those page object locators as they are defined in lines 7 through 9 in this example. So in that case, you would import the page object file into the step file. You will notice on this page object file, I have the username, which is a text input field. I have a password, which is another text input field, and I have a login button. So there are a number of ways that Selenium allows you to identify objects, and you do not always need to use CSS, but for this example, that is what works on the page. CSS can be brittle. It's better if you can use IDs or other more substantial elements that do not have the likelihood of changing. Now, you can also put your methods inside of the page object file. However, I would not recommend this for a large project because this will not scale well. If you have a large project with 25 elements on a page and 25 or 30 methods, combining them together in a file would not be a good practice or a scalable practice. However, if you are able to do a small proof of concept, then you can combine the page object file with the methods file for that purpose. So the next thing I'd like to do is show you a sample of how these tests actually work. So in this console, you will see the test running in the terminal, and you will see a browser open up. If you run your tests headless, you will not see a browser open up, but you will need to do extra setup in order for the test to run with Phantom.js. So this is the practice where you see all of the tests in the browser. So I'll press play, and you will see the console where I've written behave, and behave is the only command it actually needs. You can add more specific command line interface commands. You will see that my browser opens, and when I pull away, you can watch the test run. This is significantly faster than if I was doing this by hand. I notice the green lines in my console when the tests pass, and I notice that when they fail, I have stack traces and red steps. You'll notice that there are some yellow steps, which I will go back and explain. So overall, we have an ending report, and we have been given a little bit of help by the framework, which is built in to help testers and developers implement the proper steps. So first of all, I wrote a purposefully failing test, and in this purposefully failing test, I wrote an object that does not exist. So the then page object is gone. And you see a full traceback file all the way down, and it leads you at the top to exactly where the problem has occurred in the test code, which is very helpful. You can see that the passing steps show you exactly where they're run, and you can see the yellow step is shown up, and it's not an error. That step doesn't exist. So at the end, I have a report. I've logged the failing scenarios and where exactly they are. I have the time that the test has taken to run, and I have the yellow steps that tell me what I actually need to write in order to make that code successful. So this has been a very brief overview of the Behave tool. I believe that this tool has the power to help Python developers really engage with acceptance testing and in a way that has been previously given to people who are writing in Ruby or people who are writing in Java. So I've enjoyed creating test harnesses use this tool to help Python development shops with front-end testing. And I am not certain how I can take questions or if I can take questions, but I'd love to spend some time answering them if we have the time. I thank you very much for your attention, and I hope that you enjoy a wonderful remainder of your conference.
¿Alguien tiene una pregunta? No? I think everything was really, really crystal clear. Thank you for your explanation. Can you hear me?
Yes.
So I don't think anyone has a question for you, but thank you very much. I think you were a great speaker, and everybody understood everything.
Oh, good. I was hearing some echo, so I wasn't sure. The slides will be available, and I've made the link to the slides available. So if anybody wants to contact me, they are more than welcome.
Okay, thank you very much.
Thank you.
Otro aplauso, por favor. Thank you. Bye.
Bye.